Hello, students. In mathematics, to a mathematician, a word is just a collection of characters. It doesn't necessarily mean it's a word in a dictionary. So things like, this is a word to a mathematician. It's a word in the alphabet AB. It's also a word in the full alphabet of 26 letters, and it's a word in bigger alphabets than that. But it is a word in the alphabet of just A and B as well. So here's a question. How many words of length n have no two A's in a row? Okay, so it's a question. Let's try to solve this using Python and the fact that Python can deal with substrings. So we don't even have to check sort of the first and second character, the second and third character, the third and fourth character for an AA, because we know that the in keyword it'll check to see if, say, I want to know if BB is in here. It'll say that's true. But I want to know, is AA in here? And it'll say false, because there's no two A's in a row. So this is going to make writing this sort of thing very easy. Let's go about doing it. So I'll say no AA. So I want the number of words. I could come up with a really long title, like num words, no AA, but let's just stick with this for now, for this example. So I want to count the number of words with no AA, and these are words in A and B. Okay, so here's the problem. I need to generate all of the words and get rid of the ones with two A's in a row. Now, I don't need to do it that way, but that's probably the simplest way to do it, so let's think about that. So how could I get a collection of words that are in A and B? So let's try this. We know that the itertools library, from itertools, import product. It has permutations, it has combinations, but it also has products. So what can I do with product? Well, let's see. If I take the product of AB, and let's just grab the syntax. Let's see, does Jupyter product give me any hint? No, it doesn't. That's okay. Let's try this, and let's see. Okay, that gives me something. I think I need a repeat equals 3. So let's try this. The list of all I for I in product. Yeah, so what this is doing is it's giving me tuples. Tuples. It's not giving me the actual words themselves, but it's giving me tuples of letters, which are in A and B, which is not what I want. But remember, we have a lot of different tools. So suppose I have something like this and I want to turn it into a word. How could I do that? Well, I could try a string of that, but that's not what I want at all. It's going to include all these characters I don't want there. So what could I do? Well, what if I had AAA and I just tried to join? So I'm going to try to join this. And look, that works perfectly. So if I want to turn this list of tuples of characters into a list of just the words that are in each of those tuples, just the characters that are in each of those tuples as words, what I could do is I could say, okay, give me the set of all J for J in, and I could have given this a name. I didn't. Okay, so now I'm going to have the tuples, and what I want to do is I want to join them to the empty set, each of those, or to the empty character. And now this works. What is it doing? Well, it's taking each of these things in the product. It's using a join to make each one into a word as it iterates over all of them. So this is the product, This is the iteration. We're iterating over each of these tuples. We're grabbing them one at a time from the iterable, and then we're joining them together to get words. So let's start with this. Let's start with the collection of word lists. Well, I'll call it. We can't call it list. Remember that. That's a keyword. So word list is going to be this, except instead of repeating 3, I'm going to repeat n. So now I can have all the possible words of length n. Okay. So now that that's done, what do I want to return? Well, I want to return I in word list, and let's return it as a list. Actually, I don't need the words, I need the length. But let's first just return the words themselves. I in word list if AA is not in I. And let's see how that works. Let's see. I in word list. I have to put for I in word list. Okay. So let's check this out. I'll try no double A 2. And as you see, I'm getting the words with no 2 A's. Let's try no double A 3. I'm getting the words with no 2 A's in a row. I have 2 A's, but they're separated by a B. So I don't want any double A, and these don't have any double A. So if I want to change this function, and now I want to make it so that it's actually just giving me the number of words, well, what I could do is this. And now I can try no double A of, say, 5, no double A of, say, 6, and so forth. I can even try a list. I for I in no double A, n for n in range. Let's just go 1 to 10. And let's see, I for I want no AA of n for n in range 1 to 10. Okay. So what am I getting here? This is kind of curious. As a matter of fact, if I start with 0, it might make that even more obvious. So I got 1, 2, 3, 5, 8, 13. Do these numbers look familiar? You could pause and think about it. Well, yes, this is a sequence. I mean, we don't have the first one, but the Fibonacci numbers are 1, 1, 2, 3, 5, 8, 13, 21. So even though there's many, many different ways of generating the Fibonacci sequence, one of those many ways is with words in A and B, or C and D. It doesn't matter which characters I choose. But if we're looking for words with no double A in it, this actually counts the Fibonacci sequence. Okay. Let's try one more example. Let's just say I want to do the same thing. It's such an easy change with no AB. So we still have an A and B in here because we're taking products of things in AB, but I can't have an A preceding a B here. So I do this, and then I'm going to check to see what numbers we get. You might want to pause. Do you have a theory? Is this going to be a sequence we're familiar with? Okay, let's try again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, let's think about it. If there's no AB, how could that happen? Well, you could have, think about words of length 3. You could have BBB. You could have BBA. You could have BAA, but I can't have BAB, or I could have AAA. So since I can't have an A before a B, the A's have to all be on the right. The B's all have to be on the left. So what's happening here? Well, we're counting the number of places where we can place the first A. So here you could place the first A. Here you could place the first A after the first character. So it could be the first character, the second character, the third character, or there could be no A's at all. And this is going to be true for any value of n. How many slots am I going to have? Well, you have the first possible character all the way up to the n. So with words of length 3, there's going to be 4 choices. With words of length 100, there's going to be 101 choices. So after you think about it like that, it's kind of obvious as to what the answer should have been. but may be quite surprising when you first do the example.